Hi class, good afternoon. To start today, let's go over the homework assignment from yesterday. So get that out right now, please, if you don't already have it out. So the four things you should have out. You should have out your book, your calculator, your note packet, and then your homework. Your homework from yesterday was over section 4.1, which was on writing the prime factorization of numbers. So have that out. I'm going to read off the answers right now for you to grade it, and then I will give you credit on Monday when we're able to go over it more. So have it out right now, and if people don't have it out, pause the video right now until everyone has it out, because I'm going to go over the answers to 4.1. So going over it, it was questions 3, 7, 9, 11, 21, 25, 27, 29, 33, 35, and 37 from section 4.1 on factors and prime factorization. The answers to those questions are right here. So question 3, the factors of 16 are 1, 2, 4, 8, and 16. Question 7 that is a composite number. Question 9, that is a prime number. Question 11, the prime factorization is 2 times 5. Question 21, the factors of 60, there's a lot of them, are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. 25 is a composite number, 27 is a prime number, 29 is a composite number, 33, row 2 should be 20, row 3 should be 3, 4, row 4 should be 3, 5, and the prime factorization is 2 times 2, which is 2 squared, times 3, which is 3 squared, times 5. So it's 2 times 2 times 3 times 3 times 5. And that is going to give you 4 times 9, which is 36, times 5, should be 180. Question 35 is 2 times 29 is the prime factorization of 58. And question 37 is 5 times 17, which is the prime factorization of 85. So those are your answers. Mark which ones you missed, put how many you missed at the top, and then I will give you credit for that on Monday. So have that on Monday as well. Okay. Next thing we need to do is have our note packets out because we are starting section 4.2. So have your note packets open to section 4.2. What we're looking at now is we looked at factors. Now we're trying to find what's the greatest common factor between two numbers. We're just practicing getting a little bit of number sense. It'll be useful when we work with fractions later on a lot. So we're going to practice today. Today's topic is on the greatest common factor, and it's called the GCF, so we don't have to keep saying greatest common factor over and over again. To start though, let's practice what we did yesterday, especially if some of us were gone, by writing out the prime factorization using a prime factor tree for the following numbers or terms: 28, 34, and then 9x z squared. And with the ones that have variables with them, you need to do the number part, you need to factor the number part, and then factor the variable part separately. So let's take 2 minutes. Pause the video now for 2 minutes. Give everyone a chance to try these 3 starter questions. After it's been 2 minutes and everyone's had a chance to practice silently, you can turn the video back on, unpause it, hit play again, and I'll go over these 3. So pause the video now, please. Okay, welcome back. Let's go over it. I want to factor 28. So the way we do it is we want to break 28 up. How can I factor 28? What is 28? What's a way to write it using multiplication? I could do 1 times 28, but that's not going to be useful because then I just start where I was before. So let's start with 2. I know 28 is even, so I can do 2 times 14. 2 I can't break down anymore. 14 I can break down though. 14 is 2 times 7. And can I break 2 down anymore? No. Can I break 7 down more? No, because 7's prime. So the way that I can write 28, if I broke it down to all its parts, are 2 times 2 times 7. So I write the prime factorization of 28 is 2 times 2 times 7. And if I want to simplify that, what's another way of writing 2 times 2? 2 squared. So I can write this as 2 squared times 7. And that is if I broke 28 down to its smallest pieces. Like imagine 28 had a bunch of Legos and I broke all its Legos out. Its simplest form would be 2 squared times 7. Now we're going to try 34. 34, it's even, so let's do 2. 2, it's 2 times 17. 2 can't break down anymore, and actually 17 can't either, it's prime. So this is just 2 times 17 is the prime factorization of 34. So I just write 2 times 17. Now we're going to try 9 times x times z squared. So it looks like this. 9 times x times z squared. And when you're working with ones with variables, just do the numbers separately from your variables. So let's do 9. How does 9 break down? Well, 9 is 3 times 3, and that can't break down anymore. X, wait, that's just x. And then how does z squared break down? Well, that's just z times z. So I'm going to write this as z times z. So if I break this down to its simplest parts, it's 3 times 3, which is 3 squared, times x times z, which you could write as z squared. I'm just going to write it like that, though, just so I know. Okay, that's prime factorization, and we did it using a factor tree. Okay, today what we're looking at are common factors and the greatest common factor. Factors of a number are numbers that are smaller than your number but go into that number. Like up above, factors. We talked about this yesterday. Factors of 28 are numbers that go into 28. Those would be numbers like 1 and 2 and 4 and 7 and 14 and 28. Those are factors of 28 because they go into 28. So common factor between two numbers would be a number that goes into both of my numbers. So common factor, a whole number that is a factor of 2 or more non-zero whole numbers. So example might be, let's consider maybe 12 and 16. Factors of 12, let's list out the factors of 12. They are 1, 2, 3, 4, 6, and 12. What are my factors of 16? Well, my factors of 16 are 1, 2, 4, and then 4 again, so I'm not going to write that again. 2 times 8 is 16, and 1 times 16 is 16, so there we go. Now I want to find common factors. Common factors are factors that they have in common, ones that they share. Well, they share 1, they share 2, they share 4, and that's it. They only have 3 common factors. The greatest common factor, the GCF, the greatest common factor between two numbers, is the largest of them. So for 12 and 16, the GCF of 12 and 16 is 4. It's the largest one that they have in common. So that's how I can find the greatest common factor between two numbers, is I can just list them and then look for the biggest one in the whole group. Where are greatest common factors useful? They're useful when I'm trying to divide groups and find what's the biggest group I can make while splitting into different parts. So here's an example. A high school asked for volunteers to help clean up local highways on one Saturday each month. The group of volunteers has 27 freshmen, 18 sophomores, 36 juniors, and 45 seniors. What is the greatest number of groups that can be formed if each group is to have the same number of each type of student? So that's saying, what's the largest amount of groups that we can make so that there's the same amount of freshmen, sophomores, juniors, and seniors? So what we need to do is we need to find how many ways can I split up the freshmen into groups. So the freshmen could be split into groups of, well, one group, right, with 1. They could be split into groups of, so I'm just listing the factors of 27. The factors of 27 would be 1 and 3. I could split the 27 freshmen into 9 groups, and the other one would be 27. Those are the ways I could split up the 27 freshmen. I could have them in a group of 1. I could have them in 3 groups, in groups of 9, or in groups of 27, where they're each their own group. Factors of 18 would be 1 and 2 and 3. 4 doesn't go into 18, 5 doesn't, 6 does, that's the partner with 3, so now I'm counting backwards. 2 goes with 9, and I get 18. Factors of 36 are going to be 1, 2 goes into 36, 3 goes into 36, 4 goes into 36, 5 doesn't, 6 does, 6 goes in there 6 times, so now I'm partnering back up. 4 goes with 9, 3 goes in there 12 times, 2 goes in there 18 times, and 36 goes in there once. 45, the factors of 45 are 1, 2 doesn't because it's not even, 3, I check 45 and I've divided by 3 and now I get 15, so it goes in there. 4 doesn't, 5 does though, 6 won't, 7 doesn't, 8, nope, 9 goes in there 5 times, so that's 5's partner. Now I'm partnering back up. 3 went in there 15 times, and then 1 goes in there 45 times. Now I'm going to look for the common factors. Well, common factors are obviously 1. What are some other ones? I see 3. 3 is a common factor. Is 9. Yep, 9's a common factor. And that's it. So 1, 3, and 9 are the common factors. The greatest common factor is 9. So that means the greatest number of groups that can be formed would be 9 groups. I would have 9 groups. If I did 9 groups, that means in each group there would be 3 freshmen, 2 sophomores, 4 juniors, and 5 seniors in each group. So if I made 9 groups, this is what one group would look like. Maybe here's group 1. I know there's going to be 9 of those groups because I wanted the greatest number of groups. If I divide each of the 27 freshmen by 9, that means there's going to be 3 freshmen in a group. There's 18 sophomores. If there's 9 groups, it means there's going to be 2 sophomores in each group. There's 36 juniors. If I divide them into 9 groups, it means there's going to be 4 juniors in each group. And if I take the 45 seniors and divide them into 9 groups, it means there's going to be 5 seniors. And there's going to be 9 groups with exactly this amount of freshmen, sophomores, and juniors in each group. But there's an equal amount, so there's no favoritism going on. What I want you to do in this checkpoint is I want you to find the greatest common factor of the following numbers. Find the greatest common factors of 8 and 28, and then find the greatest common factors of 12, 18, and 30. And the way to do this right now is just going to be to list out the factors of each number. So I will do the 8 and the 28, and then I'll leave you to do the rest. So the factors of 8 are 1, 2, and then 2 and 4 go together, so I know I'm just going to pair off 1's buddy, and that's 8. So there's the factors of 8. Factors of 28 are 1, 2, 3 doesn't, 4 goes in there 7 times, so 4 is going to go in there. 5 doesn't, 6 doesn't, and now we're at 7. That was 4's partner, so now we're just partnering back up. 2 goes in there 14 times, and 1 goes in there 28 times. Now, find the greatest common factor of 8 and 28, and then do that also for 12, 18, and 30. So try those. Pause the video for 2 minutes. Give everyone a chance to list out all the factors for 12, 18, and 30, and then pick off the greatest common factor for checkpoint question number 1 and number 2, and we'll come back to it. So try those in your work packets now, please. Okay, welcome back. Let's go over it. If I look at question 1, I've listed all the factors. What are ones they have in common? They have 1 in common. They have 2 in common. They have 4 in common, and the biggest one they have in common is 4. So the GCF, the greatest common factor for this, is 4. That's the biggest number that will go into both 8 and 28. 12, 18, and 30, I need to first list off the factors. The factors of 12 are 1, 2, 3 goes into 12. 3's partner is 4, so now I know I'm just partnering back up. 2's partner is 6, because 2 times 6 is 12, and now 1's partner is 12, because 1 times 12 is 12. Now I need 18. 1 goes in there, 2 goes into there, 3 goes into there, 4 doesn't, 5 doesn't, 6 does, and 3's partner is 6, so I know I'm just going to partner off on the way back. I don't need to worry about any of the others. I just say I work backward. Now 2 goes in there 9 times, 1 goes in there 18 times. Now I'm at 30. 1 goes in always, 2, 3 goes in there, 4, nope, 4 doesn't, 5 does though. 5 goes in there 6 times, so the next number is 6, 6 goes in there. 5 and 6 are partners because 5 times 6 is 30, so now I'm just partnering back up. 3 goes in 10 times. Now I go over here, 2 goes in 15 times. My last one is 1 needs his partner, and that's 30. I've listed out all the factors, now I just need to find the biggest one. So the common ones are 1, 2, 3, not 4, 6 though. Are there any others? Nope, 12. Nope, so the biggest one that they have in common, the greatest common factor of 12, 18, and 30 is 6. That's our first way of finding the greatest common factor, is just to list them all out. And it's not a bad strategy, it just takes a while, so you have to kind of be patient with these ones. Maybe we can find a faster way, and you can. So the second tool that we have for finding the greatest common factor is this. So flip to the top of the next page. For larger numbers, you will want to construct a factor tree and pick off the common factors. Once you have all of the common factors, then we can multiply them to obtain the greatest common factor. So for numbers like 28 and 63 and 42 and 55, sometimes when you list out their factors, it might take a while. Like when we saw the homework yesterday, 60 had a lot of factors. So maybe let's try to find a quicker way to do this. And this is a quicker way to do it, is you make a factor tree and pick off the common factors. So here, let's do 28. I'm going to make a factor tree for 28. 28 is 2 and 14 and 2 and 7. We did that at the start. So 28's factor is 2 times 2 times 7. Now let's do 63's. 63, his common factor, or his factor tree, I could think, no, 2 doesn't go in there. Does 3 go into 63? It does. It's 3 times 21. And now, does 21 simplify? Yeah, it does. It's 3 times 7. So 63's prime factorization is 3 times 3 times 7. What's all the ones that they have in common? Well, they just have 7 in common. So the greatest common factor of 28 and 63 is just 7. Okay? Let's try 42 and 55. So I'm going to make the prime factorization for each and then find the ones that they have in common, and then I'm going to multiply them. So 42, it's even, so it's going to be 2 times 21. The prime factorization of 21 is 3 times 7. So those don't break down anymore because they're all prime. So the prime factorization for 42 is 2 times 3 times 7. 55, well, 2 doesn't go in, 3 doesn't, 4 doesn't. I know 5 does. It's 5 times 11, so let's just use that. And hey, 5 and 11 are both prime. So 5 times 11, well, let's look at these. 2 times 3 times 7, so they don't have anything in common. So their greatest common factor, the only number that goes into both of them, is the number 1. And we say when two numbers, the only factor they have in common is 1, we say that those numbers, this is a vocab term, you need to write this down. We say they are relatively prime. It means the only prime number, the only common factor that they have in common is the number 1. So 42 and 55, these two numbers are relatively prime because their greatest common factor is 1. That's a definition. You're going to need to star it. It might be a homework or it might be a notepad question for the quiz. You try then for 30 and 49. Try that checkpoint. So pause the video now for maybe a minute. Make the prime factorization tree for 30 and 49 and then find the greatest common factor that 30 and 49 have. Okay? If the greatest common factor they have is 1, then those numbers are relatively prime. So pause the video now, and we'll go back over it once you've had a chance to try. Okay, welcome back. Let's try using our new tool of making a factor tree and picking off the common factors and then multiplying. So 30, I know it's 3 times 10, so let's just do that. You could also do 2 times 15, it doesn't matter. 10 is 2 times 5, so I'll write it as 2 times 5. And now I have it. I'm going to write it from smallest to biggest number. It helps me keep things organized. So I know that it's just going to be, I'll write this, I can just write it as 2 times 3 times 5. Now let's do 49 over here. 49 I know is 7 times 7. And both of those are prime, so it doesn't simplify anymore. So 49 is 7 times 7. Now I look, do they have any factor in common in their factorization tree? They don't. So their greatest common factor is equal to 1. And if it's equal to 1, we say these numbers are relatively prime. They really don't have anything in common. They are relatively prime. It's kind of special to be relatively prime, so that's why we have a special name for it. Last thing we're going to look at is kind of a challenge, but I think you guys are up for it. What it is we are going to find the greatest common factor, not when we have just numbers, but when we have terms, monomials going on. And the way you do this is you find the greatest common factor for the number and the variable separately. So what we're going to do first is let's find the greatest common factors of the numbers first. So I'm going to take my numbers. Let's do 16 and 26. I want to find their greatest common factor. What's the biggest number that they have in common? So over here, I'm going to list out the common factors of 16. You can make a tree, or you can just list out the factors. I just like listing out the factors because at this stage I think it keeps things simplified. So let's list out the factors of 16. I know 1 goes in there, I know 2 goes in there, I know 3 doesn't, I know 4 does, and 4 is its own partner, so now we're just pairing off backward. I just need to think now what is 2's partner. It's 8, because 2 times 8 is 16, and 1, his partner, is 16. So there's the common factors of 16. Now I need the greatest common factor of 26 with 16. So let's list out the factors of 26. It's 1 and 2, and 3 doesn't go in there, and 4 doesn't go in there, and 5 doesn't, and 6 doesn't, 7 doesn't, 8 doesn't, 9, nope, 10, 11, 12, nope, 13 does though. And because 2 and 13 are pairs that make 26, I know I'm just counting backward now, so I don't need to check any of the other numbers. I know it's just going to be 1's partner, and 1's partner is 26. So let's look. What's the greatest number they have in common? They have 1 in common, they have 2 in common, and the biggest one they have in common is 2. So the greatest common factor is going to be for the numbers. It's going to be 2. Now let's do the x's. There's x squared here, x squared here. So I'm going to list off the common factors for x's that they have. Well, let's look. This guy has x squared, this guy has x squared, and hey, that's what they have in common. They both have an x squared. So what do they have in common? They have x squared in common. And last part is let's do the y's. So y and y cubed. So this first one is y, and now we have y cubed. What are the factors of y? Well, the only thing that goes into y is y. And what's the only thing that goes into y cubed? Well, what goes into y cubed? Y goes into y cubed once, y squared goes in there, and y cubed goes in there. And the biggest thing that goes into there that they have in common is just one y. So the most amount of y's that they have in common is one of them. So I'll write that over here. The biggest things that they have in common is they have 2 1's, they have x squared in common, and they have a single y in common. So the greatest common factor is 2 times x squared times y. Do the numbers separately and then do each variable separately. So over here, the reason that they had x squared in common is because if I list each of them had x squared, the factors of x squared are x and x squared, and the biggest one in common is x squared. Okay? You try with this one. Now there's just going to be, I'll simplify it a little bit, just numbers and x's, not x's and y's. I want to find the greatest common factor of these monomials. So we got to do numbers separately, find the greatest factor of 12 and 18. What's the biggest number that goes into 12 and 18? And then let's do our x's second. What's the most amount of x's that they have in common? What's the most amount of x's that go into both of them? So your first job is to find the factors of 12 and 18 and find the biggest one. And then do it for the x's as well. So x cubed and x squared. Find what's the most amount of x's they have in common. So pause the video now. Let's take a minute and a half for this one. Pause the video now. Come back after everyone's had a chance to try, and it's been a minute and a half. Okay? And then we'll go over it. Okay, welcome back. First thing we need to do is list off the factors of 12. Factors of 12 are 1 and 2. 3 goes in there. 4 goes in there. And because 3 and 4 are the partners, I know I just need to partner off 2. 2's partner in this is 6, because 2 times 6 is 12. Now 1's partner is 12. Now I know I'm done, because once I partner the middle ones, I just need to partner the rest. 18. His factors are 1 and 2 goes in there, and 3 goes in there, and 4 doesn't, 5 doesn't, 6 does though, and 3 and 6 are partners. They're the factors that make 18, so now I just need to partner off 2. 2's partner is 9, because 2 times 9 is 18, and 1's partner is 18. So there's all the factors of 12 and 18. What are the common ones? The common ones are 1 always. 2, hey, 3 goes in there. Hey, 6 goes in there. So the biggest one they have in common, if I'm going to list out the greatest common factor, the biggest number that those two monomials or terms have in common is they have a 6 in common. Now let's do the variable part of each term. X cubed, how many x's go into x cubed? Well, I could have 1x, I could have x squared, or I could have x cubed. That's the most amount that'll go into x cubed. What about x squared? I could have a single x, or I could have x squared. That's the most amount that'll go into x squared. What's the most they have in common? Well, they both have an x, and they both have x squared. So x squared is the most amount of x's that go into both. It's the biggest number of x's that go into both. So the greatest common factor for x's is x squared. And I'm done. The greatest common factor, well, the biggest number they have in common is 6. The biggest amount of x's they have in common is x squared. So the greatest common factor, the GCF of those two guys, would be 6x squared. If you got it, give yourself a little pat on the back. Do it right now. Pat yourself on the back. Those are challenging, but I think you guys are up for it. That is the end of our notes for 4.2. So have those filled in. I'll check it to see how it went when I'm back. The last part then is going to be working on the homework. So for the rest of the day, you have time right now to be working on the homework. The homework is day 2 on the assignment sheet. It's on 4.2, greatest common factor. It's page 179. The numbers are 3, 7, 9, 13, 17, 21, 25, and 29. And you need to be working for the rest of the period quietly on your own, so we can get a good report back. And then also when we get back on Monday, we won't have to review much because you guys did awesome and used your time wisely, so you don't have any homework over the weekend. So that's your assignment. Use your time right now to get it taken care of. And then I will see you in a couple days. Thanks.